Okay, I think we'll kick it off. Thanks for jumping on, everyone. I'm assuming some of you were on yesterday, some of you may not have been, but welcome. So my name's Scott Leggett. I'll give a quick introduction to what we're going to be doing today, and then we'll hand it over to Josh and James to run the certification. But I lead our customer success organization here in Asia Pacific. So I just wanted to welcome everyone to today's Cloud Security Analytics certification. Hoping you all get a lot of value out of it, and we thank everyone for jumping on and investing your time in learning more about Sumo Logic. So with that, we've also got Josh on the call, who's our training manager. So Josh, did you want to say hello?
Hey guys, there we go, camera on. Hello everybody. I'll take over from Scott in just a second. So welcome to those of you that weren't here yesterday.
Thanks, Josh.
Welcome back.
And we also have James Ashburn on the line, who's our pre-sales solution architect based in Sydney. So James, did you also want to say hello?
Yeah, hey guys, welcome back if you're returning from yesterday, and welcome, if you're new. So I'll be answering the Q&A in the chat area while Josh is presenting later. So feel free to pipe in with questions. You're not going to disturb Josh at all.
Thanks, James. Let's go to the next slide, Josh. So yeah, if you're on,
do you want to go through this?
Do we want to go through it again?
Learning helps. We find users that use Sumo more those who learn more about it use it more. So, but go ahead, Scott.
In summary.
Let's do the next one. At least who's here.
Cool. All right. Thanks, Josh. So, yes, look, I think we've got 22 people on the call. So, given it's 9 a.m. in Australia and 11 in New Zealand, I'm assuming most of you on the call are from either one of those countries. I'm personally based in Melbourne, Australia, but wherever you're from, welcome. We do have a very large customer community across ANZ, but also broader Asia Pacific as well. That's probably a little bit too early for anyone in Asia, but if you are coming in from Asia, welcome as well. But Josh, I believe I'll hand it over to you now.
Yeah, thank you, Scott. So I'm going to turn off my video just to save a little bandwidth. I was getting a little chunky earlier. Welcome back to those of you that are back, and to those of you that are new to this, nice to meet you. So yesterday, what we did is we did our fundamentals class. So what we did is we went through the fundamentals of Sumo Logic. What is Sumo Logic? What is a query? What is a dashboard? And if you joined us, hopefully you learned that stuff. You may know that already, which is great. What we're going to do today is we're going to go over what we call cloud security monitoring and analytics. Essentially, what we're going to do is use the query language like we started to do yesterday, and use it for cloud security. So start to look at, is somebody attempting a brute force attempt? Is somebody logging in from 2 different places around the world in a time span that is kind of fishy? And those type of things. And so what we're going to do is, once again, kind of just dive in and do some labs together. For our schedule, it's going to mimic what we did yesterday, but if you weren't here, basically we have 3 hours together. So countdown has started already. We're going to do about basically our day is broken out into 3-hour block, 2 hours for content, 1 hour for an exam. So you'll take an exam at the end of today, as you did yesterday, if you were with us. And the front half, the first 2 hours, is going to be going over cloud security. So I have a couple of slides, but then we're really going to get deep into labs. So yesterday we did demo slides, labs. Today is pretty lab heavy, which I think will be good. I enjoy it, at least, and I know other students do. So I think you'll have a kind of a good time with it. And then we'll take a break, roughly in about an hour and a half or so. And then we'll come back, we'll do a few more labs, and then we'll take the certification and call it a day. So once again, as Scott and James mentioned, questions, please bring them in. Go ahead and put them in the Q&A. So for questions, Q&A, if we will use the chat though. So if there's, if you're having a little problem, or I might ask you to verify that you logged in, use the chat for that. But questions and answers, Q&A is a good place. Where we go. As a reminder, we have some bonuses for you, I guess. So we want to reward you with a Uber Eats gift card. So when you complete a certification with us, a class and a certification, and then email that to training@sumologic.com, we'll send you an Uber Eats gift card. So please take advantage of that. The other promotion we have going on is if you complete 6 of our certifications, and we currently have 10, we'll send you this cool backpack. We'll put back this information later, so don't worry too much about the details, but we'll remind you of these bonuses later. Yeah, let's dive in here. So let me go ahead and load up my other deck here. I do have a deck just to kind of start, but I don't really use it too heavily. Oh, and it's right in the middle of it. Sorry. There we go. So, welcome to security monitoring and analytics. So that's what we're going to be doing today. And so as described, our agenda, sort of what I was trying to allude to. So intro, we're doing the intro already. Going to do a quick demo, just show you a dashboard and some panels within it. And then we're going to do some hands-on labs and then do the certification. So I think you'll enjoy today, especially if you came back from fundamentals. That's a positive sign. So yeah, away we go. And we have a whole bunch of new people that joined in the past few minutes. So good to see. Once again, the promotions, and I'll remind you about those again. But let's get to the meat of what we're talking about today. Now, we actually did this slide yesterday. I'm going to go over it quickly again, but just as a reminder, because some of you haven't seen it, just a reminder of kind of Sumo Logic, who we are, what we do. The short version of this slide is we can help you, and you've already kind of bought into that. So this is not meant to be a sales pitch of why is Sumo great. You and your company know why we're great. Joking, of course, but Sumo can help you in a variety of different ways. So operational intelligence, looking at MTTI, MTTR, seeing that things are up and running, which we sort of did a little bit yesterday, but security intelligence, this is what we're going to be focusing on today. So using Sumo for security. You can also use it for business intelligence, use it for global intelligence, many uses for Sumo. Where or how does Sumo work? Well, it relies on your data. Your data is going to be key to evaluating your business, your organization. And that data is going to come from many sources around the world. It's going to come from apps. It's going to come from cloud. It's going to come from a server sitting in the warehouse. It's going to come from your laptop and more or less places as well. Using our analytics, well, Sumo's great. We can help you with that data. So we are multi-tenant, we're scalable, we're elastic. Things can be up and running and easy to access. Machine learning's built in. APIs, we don't really go into the APIs too much, but full API usage. Advanced analytics, and we're going to look at some more of those analytics today. And then certainly security monitoring, which we're really going to be focusing on today. And then who can benefit from Sumo? Well, fortunately, everybody in your organization can, regardless of if they're DevOps, SecOps, customer success, everybody can use Sumo. And so that's what this slide is kind of showing in a nutshell. Now, to zoom in kind of a little on the security intelligence solution side of things, because that's we're focusing on security today. Sumo has 3 security intelligence solutions. The first one is audit and compliance. Sumo's great to help you with, there we go, with helping you to make sure that you're compliant with whatever compliancy needs you have, whether they're internal, external, government-based, regarding data collection and ingestion, how long data is stored. Sumo can give you a great view into that data and help you and others understand how your data is being utilized. Security analytics. Well, this is what we're going to be talking about today, using searches, dashboards, and advanced analytics to get security value out of Sumo. And then Cloud SIM. We're not covering Cloud SIM today. Maybe we will probably in the very near future, but Cloud SIM is an add-on product that's really helpful for threat correlation. What it allows you to do is using this heads-up display and other tools allows you or the system really to start to analyze traffic, analyze data, and I'm using data kind of generically, but data, and start to look for security threats, security trends, and let you know about those things before they happen, so that you can be told that, oh, this behavior is sort of suspicious, and then you can go into the environment and look at the experience that somebody is doing and decide, is that bad, is it good, and go on from there. So really cool product, or add-on product, I guess I should say. If you're interested in it, I'd probably encourage you to reach out to your Sumo contact. That's probably the best action. But like I said, today we're really focusing on this middle panel, security analytics. And then within security analytics are the 3 kind of areas we'll be focusing on. So searches, you saw searches yesterday. You'll learn what searches are if you don't, but the idea of using the query language to slice and dice the data. using those dashboards to take that data you just sliced and diced and present it in a way that might be pretty. It might be just more beneficial, better to understand. Many reasons why you might want to use dashboards. And then those advanced analytics. So we'll use some of those advanced operators like geo lookup and some others that are pretty powerful and can allow you to do some pretty cool things. All right, a quick demo. It's not even really a demo. It's really just showing a dashboard. So don't look at that yet. Let me show you this. So what I have here, there we go, is a dashboard. And so as we saw yesterday, you can create dashboards, and we're going to create dashboards today. But I have one that I or somebody in my organization created. And so what I want to show on here is some things that we've created, and we're going to then replicate some of these things, or similar, at least, maybe not full duplication, once we get into the lab in just a few minutes. So the first one, for example, top left, I have SSO and non-SSO login locations. And I have a map. So this is very clearly, once it expands out, come on. It's not expanding. But what it's showing is a map of where my users are logging in from. Now, why is this relevant to security? Is it relevant to security? Maybe, maybe not. But this can be quite telling. So here we have our map, for example. I may want to know where users are logging in from. And when I see users logging in from places that I don't expect, this could be a security event. Now, it may not be, but it's going to help me in starting to determine things. So for example, like we were saying yesterday, and as a reminder, I am US based. So I am in California, Oregon, right near California, same time zone. But let's say I'm US centric. My company's US centric, and I only care about the US like US people do sometimes. This might be interesting to see that people are logging in from Africa and South America. If I don't have any, let's say I am fully US centric and I see these logins, this might be quite curious to me. Now, let's say I'm US centric, but Bob on the DevOps team, he took a trip to South Africa this week, and he's doing work from there. Well, then it would make sense why somebody's coming out of Africa. If he doesn't or hasn't, and nobody is physically there or doing any testing with VPNs, and we see traffic coming out of Africa and South America, then that might be curious. Is it a security event? No. Is it potentially though? Maybe. And so that's where you kind of need to put on your hat, if you will, and start to kind of decide that. And so what we're going to do with Sumo Logic, or Sumo Logic is going to do for you, is let you know about these things that are curious, and then you'll need to decide, are they legitimately hackers trying to take down your system, or is it Bob forgot his password and that's what's causing an issue? And we'll use kind of Bob and passwords a little bit. I don't think we have any Bobs today on here, so we'll use that name as our kind of guinea pig. But certainly a map can be quite helpful in giving you a visual of where people are logging in from. Now, once again, this does include VPN. So just because someone's logged in from South Africa does not mean they're physically there. But this data can show you, what it shows you, if you will. Another chart or dashboard panel here is this threat intelligence. What we're doing here is we have a partner with this, but what is occurring is the system is looking at, in this case, IP addresses, and then deciding if they are, how bad are they, and providing a malicious confidence as a score, essentially. And so what we're seeing here is that 124 IP addresses over the last 60 minutes, have a high maliciousness, meaning that they could be bad actors. Now, once again, maybe it's somebody on our team testing as a bad actor or something like that, but that's what this is starting to show us. There was a question about, is the color related to so the colors here. So these are not related to security evaluation. It's simply quantity. Basically what it's doing is if the value is from 1 to 10 or 1 to 9, it shows up as green. 10 to 100, it's yellow, and then red is I think 100 and above or 200 and above. So it's doing it just based on quantity. So yeah, that's what's occurring there. All right, so let's see, that's threat intel, and we'll talk about threat intel in more detail later. Suspicious login distances. This is one we'll replicate, sort of. to some degree. But what this is showing us is here we have Damon. And what this is showing us is over the last 24 hours, he has logged in from the United States and Egypt from these specific IPs. Now that's kind of curious. Or is it? Certainly Damon could have, been in the US, done some work in the morning, gotten on a plane, flew to Egypt and done some work in the evening, and that could occur within a 24-hour period, and that might make perfect sense of why Damon is showing in that way. If Damon did not do that, that might be curious. If Damon is on vacation in Australia, this would be kind of weird. If Damon is no longer with the company, this gets even weirder. If Damon's job is to test VPNs around the world, then this is just normal behavior. And that's once again where we show you what's occurring, and then you need to decide, or with the help of other people, maybe go to Damon's manager and say, hey, this is what Damon is doing. Is this what he should be doing? Yes, he should be logging in from different points around the world. Great, he's doing a good job. No, Damon was let go 3 months ago, and we were supposed to have disabled his credentials. Well, then this becomes, more problematic. A couple more here. Let's see. This one on the right is very straightforward as far as just bytes in, bytes out, bytes sent, bytes received, which, for firewall traffic can be quite helpful. So, and certainly a spike could be quite telling of some sort of large data exfiltration taking place or something like that. This one right here is outlier. I discussed it yesterday, briefly, and we see it again here. But where it's helpful, once again, is just what it's doing, in that it's looking at our firewall traffic volume. It's displaying this gray, I guess that's the color, gray line or so, representing what the actual traffic is for this moment in time over the last 60 minutes, and then showing us these pink triangles representing times where volume was higher than what was expected. So what we see here is over the last 60 minutes, there's been 6 times where there's been higher firewall traffic volume than what is normal, and the system's letting us know that. Now, once again, does that mean a great hacker is in there? Maybe, maybe not. Probably not, but it could. If we're seeing this is abnormal and this is occurring at the middle of the night, showing when systems are normally down and we're seeing spikes, maybe somebody is doing something. Maybe somebody is just taking advantage of they can't sleep and they're up and they just happen to be uploading a lot of data. That's where you need to decide. One other thing I should have mentioned, it's minor, I guess, but just with the times here, they are, once again, me being US centric, my times are local for me. So when we get into the labs, your times will be local to the US as well. It's not going to really matter too much, but just to kind of point it out. So that's, just wanted to show you some of these, and we're going to replicate some of these and make some modifications to them as well. So let's go ahead, or let me go ahead, and let's log into the system. So same way we did yesterday, we're going to log in. If you remember the whole login sequence and credentials, go ahead and log in right now. But otherwise, let me go ahead and put them in here for you. There we go. So once again, it's going to be service.sumologic.com. It's going to be training plus analyst number at sumologic.com, and you're going to pick a 3-digit number. If you have a 3-digit number that you've used previously yesterday, please use it again. If you want to use a different one or the same one, it doesn't really matter too much either way. Password is going to be capital SECURITY 21 exclamation point. Yeah, just let's go ahead and get logged in. If you need help, of course, please let us know. If you get a bad password or something like that, try a different 3-digit number. It's possible somebody was in there and locked themselves out, and that could be the issue. I'm going to go ahead and let me log in as well. And once you're logged in, if you could just let me know, either type in or just type the 3-digit number, just so I know we're sort of together. Oh, there we go. Cool. Thanks, everybody. I'll wait a few more minutes. No, I was going to say no rush. I mean, a little bit of a rush, but no, we'll make sure everybody gets in together. And also, let me go ahead and share the labs as well. So why can't I not log in? Oh, hold on. All right, just 1 second. Sorry about that. Training. So I am now logged in, and let me go ahead and share those labs as well. All right, I'm going to go ahead. There we go. Pasted those into the chat, so hopefully you can see them. When you click on them, they should take you to this page. And so ultimately, you'll have Sumo Logic open. Let me clean this up a little bit. And you'll have the labs open, and then Zoom as well. All right, so just once again, credentials. Everybody, I think, is logged in or pretty much logged in, and I think James is helping others. And make sure you have that lab guide handy. All right, so away we go. So let's start with lab number 1. So lab number 1 is about monitoring user activity. As it says, monitoring user activity will help us understand what users are doing. In this case, we're going to be using AWS data. We're going to alternate a few different sources of data. The first couple of labs are AWS CloudTrail data, just because it's popular, in case you didn't know. But we just, yesterday we used Apache. We just use different ones to show different features. And CloudTrail is going to be a bit unique. We didn't look at this, this feature of the data yesterday, and somebody actually asked a question about it, so this will be helpful. So what we're going to do in this lab is, as it says, create a query that's going to show the top 10 AWS activities with user information. So how are we going to do that? Well, like we did yesterday, we're going to utilize the query that is created for us. We're not going to create our own queries in this class. But what we're going to do is, like we did yesterday, kind of copy and paste them in and then run them and see how they work, and then add more lines and see how those work, and build upon it. So let's go ahead and start. Now, in lab activity 1 is the portion that we want to grab, and I'm going to grab all of it. So I'm going to copy it, and then I'm going to do a new log search, and I'm going to paste it in. Once again, when you're in Sumo, you either want to, ideally you want to be on the home page. If you're not, that's okay. And if you're on the home page, you can go to log search, or you can go to plus new and go to log search. As a reminder, many ways to do the same thing within Sumo Logic. So ultimately, you should have this query in here. Now, what I'm going to do here is I'm going to comment off the bottom 3 lines, because I want to go line by line and show you what's occurring here. The other thing I'm going to do is expand my search out to the last 24 hours. The query or the lab wants us to do the last 24 hours, and so I'm going to obey the lab. So I'm going to look for this last 24 hours for this query, and click start, or click the search icon. Now, remember, I didn't do these last 3 lines. Right now, I'm just doing this first line, and I'm doing it intentionally because I want, like I said, I want to show you something about the data. In fact, let me show an example of the difference here. Now, a little bit of a tangent from the lab, but in a good way. If you remember yesterday, and if you weren't here yesterday, not a problem, but what we did is we looked at Apache access data. And here's an example of one of the messages we looked at, or a similar type of message. If you remember, it had an IP address, it had a status code, it had a size, it had a URL, a refer, it had all this information. And one of the exercises we did is we parsed the information out. We essentially trained the computer to recognize this is an IP address, this is a status, this is a size. And so we did that training through parsing. Now what I'm going to do is run this AWS CloudTrail data. And what I want to show here is the fact that these messages are structured differently. If you notice, it has an IP address like that other message did, but it has a field or a value, well, it's a field called source IP address. This is AWS data, so it has different regions of where your data can reside. Here is the field for AWS region, and here's the value for that region. And so what I can do here, or what is happening for me, is the system is parsing this data automatically. The reason it's parsing this data automatically for me is this data is in a format called JSON, JSON. It's a popular format, and one of the advantages of it is it does exactly this. It allows users or people, I guess anybody really, more structure within their data. It's more verbose as well, so it does take up more space, but this is one of the benefits of it. And so what it's doing is it's automatically providing me these fields. And so I could automatically start to search on these fields. Now, what I'm doing with these next 3 lines is I'm renaming the fields. So what I'm doing here, for example, I'm going to use, I'll look, let me just do this too. For example, this line right here, this 3rd line. What I'm doing here is I'm saying, take the field that's called source IP address in the JSON file and rename it, call it source IP. Why? I don't know if I really need a good why reason. I want to. I mean, I would have a good reason. It might be more standard usage in our organization. It might match up with other fields, but I can go ahead and just rename them. And that's what I'm doing here. So when I run the query with all 4 lines, what I'm going to have is my data, that CloudTrail data you just saw. And then I'm going to have 3 fields rather, excuse me. A field for actor, which is essentially user. A field for event type. What did this user do? They did an AWS API call. And the source IP address. Where did this user do this API call from? 67.220, etc. So now I have a query of, over the last 24 hours, what my users did, who those users were, and from what IP address they did it from. Now, the goal of this lab is to get more specific. We want to find the top 10 activities, but I'm starting to get there. I'm starting to get my data formatted in that respect, in that way. Now, what I'm going to do here, or I'm not going to do it, it shows you can do it, is you can parse the data using the method we did yesterday. So that's what we're showing here with this step, this one here. I'll show it both ways. Is you could go ahead and highlight, where's event name, and parse it and give it another name. Or you can do it just by typing, and that's what we're doing here. What we're doing is very simply taking the field of event name and just renaming it. We prefer to have or I prefer to have a underscore in there. Why? Well, once again, it's my decision. I want to. And so that's what we're doing here, is trying to rename some of those fields. And so we have, congratulations, we've run 5 lines of code, which is great. And so just to make sure I'm running it properly, once again, I should have my data, and then I should now have 5 fields, because I'm going to, excuse me, I keep adding a field. I should now have 4 fields, because now we have another field for event name. Now, what we're going to do next here, this is going to be, it might seem a little weird, but there's a reason for it. So I'm going to show the steps, and then I'll show why we do it. What we're going to do is we're going to add this line here in step 5, where event underscore type matches event underscore type. Now, why am I adding a line that looks repetitive? Event type and event matches event type. Well, there's a reason for it. What I can do is I can turn on or create a filter called a parameter. Because let's say I have these different event types in here, or these different event names. Well, let's use event types. That's what we're talking about, event types. Now, what if I just want to search for a specific event type? How do I do so? Well, that's what I'm going to show you now, is how to create a quick filter to do that. So let's do it. What we're going to do is we're going to highlight the second event type. And when we have it highlighted, there should be this create a parameter box that, or just phrasing that pops up. So right now there's nothing there. When I highlight event type, I have this option to create a parameter, which I'm going to select. Once I'm in here, what I'm going to do is just rename the parameter one to call it event type. So event type, and I'm going to click save here. What that now does is gives me this parameter option over here. What I can now do is I can go ahead and put a wildcard in there and I could search for all event types. Or what I could do is just search for AWS API calls. And now I'm going to filter just on that. So it's giving me this interface to start to filter. I could create my filter in here and I could just say matches AWS. I mean, I could just do that, but it's not as versatile. As you see now, if I want to change that again, I have to manually adjust the query. And so we're going to use these filters. Well, now we're starting to use them, but we're going to start to populate them. And what we're going to do in a few moments is we're going to start to put these into a dashboard and then have a dashboard where we can apply a filter to a couple different panels at the same time, which is pretty helpful. All right. So hopefully you're up to the same, pretty close to the same step I am, where you have everything in step 8. So you have this event type matches event type. You've turned it into a parameter. And you're ready to go. Any questions, of course, please ask, but otherwise let's go ahead and continue here. What we're going to do to continue here is we're going to add some more lines of code. So I'm going to grab these 4 lines of code. I'm going to paste them in, but I'm not going to run them all at the same time because I want to go line by line like I've been doing, which I hope is an effective training method. So what I did is I added this line of where actor matches actor. What it's going to do is basically do the same thing as the event type. And so now we have 2 filters. We can search on event type and or we can search on actor, user, and we will shortly. So now I've created those parameters. So I have my data, I have my parameters, but now what we want to do is kind of fulfill the lab, which was creating a top 10 list. That was kind of the whole point, is to do a top 10 user list or top 10 activities. So now we're going to do that. What we're going to do with that, or how we're going to do that, is this next line, and we're going to count the data. So essentially, what do we want to count? Well, we want to count the actor or the users. We want to count the event types because we want to know what they did, and the event name as well as also what they were doing. When I run this line that has count in it, I'm going to get a new tab called aggregates. And if you're with us yesterday, you remember, hopefully remember, that the reason we get the aggregates tab is because we're running a mathematical operator essentially. So we're running count. Count is showing us the results of math in the aggregates tab. We still have all those raw messages, but now we also have the sum of those, or the grouping of those messages, the count of them. Now with this count, I see 10 pages of data, 25 per page. So I see about 250 actors with different event types with different event names. But the goal here was to find the top 10 of those. So how am I going to do that? Well, once again, kind of 2 ways to do the same thing. I can go ahead and just click on the count column and just sort it from high to low or low to high. And now I see my top 10, but I also see my top 11, my top 20, I see more than that. If I want specifically the top 10, I can use the top, and top is an operator. The top X, the top what, the top 10. The top 10 what? The top 10 users or actors. And I want to do it by event type and count. So now when I run that next line, I have my user, I have my event type, and I have my account of those top 10s. If I wanted to do top 20, I could have done that and would just take that list and put them together. I do need to click on it to sort them, which is, it's intentional design, but I do need to do that. Actually, you can also sort them automatically. Now, the next thing we're going to do here is transpose the data. As we looked at yesterday with fundamentals, and if you weren't here, perfectly fine. We have in this case, and I think I'm using the term correctly, but we essentially have 3 dimensions of data, different data points. We have our users, we have our event types, and we have our count. Well, by transposing the data, we can put this into an Excel look and feel where we have rows and columns. And that's exactly what I have now. Now I can very easily see over the last 24 hours, Ankit has done 1,200 AWS API calls and 14 or 1,300 console sign-ins. And once again, does this mean that Ankit is a bad actor? Yes or no. If he's on vacation, this is confusing. If he's should sign in to do his job, but 1,300 sign-ins in 24 hours, that might be curious. It might not be, depending on his role. And so that's what we're starting to be shown here. All right. So we should have run this. We should have gotten our little chart here, and hopefully we're together with that. Now, what we want to do next is we want to go ahead and, we want to go ahead and turn this into a chart. So as we saw yesterday, and I shouldn't keep saying as you saw yesterday, you may, it doesn't matter if you were here yesterday or not, but we can take this data and we can, or we are automatically portraying it or viewing it in a tabular view, but maybe a more graphical view would make sense. Maybe a bar chart, a line chart, a pie chart would make sense. In this case, we're encouraging you to use a bar chart, but it doesn't matter. Feel free to use whatever you'd like. You can go ahead and click on the gear icon to change things about the chart. So you can change the legend. Where does it show up? You can change the colors. That's a big one. You can change the color schemes. Once again, just to make kind of look and feel that you prefer or your organization prefers. And so go ahead and put it in a way that's, you don't have to use red if you don't want to. All right, so pausing again, hopefully we're together. This lab goes over a lot of different things. I forgot how much it covers. And there's still another portion here that we're going to go through, but hopefully this is interesting and sort of helpful. What we want to do now, though, is we want to utilize a lookup table. Because right now, when we have our parameters here for event type and actor, I need to type them in, and I need to know what they are. The system is not populating the values for actor. It knows what an actor is, but it's not providing those values here for me, and I'd like it to. Because I don't know who all of our actors are. I know Ankit's one, but I might not know the other names. So how can I utilize a lookup table? Well, that's what this lab's doing right now. What we're going to do is we're going to really just follow the steps here. So we're going to go to our parameter, our event type. We're going to go ahead and click on the three dots, and we're going to choose manage parameter settings. Excuse me. We're going to go ahead, and towards the bottom of the pop-up is going to be kind of more of a pop-up. So we're going to go to this bottom portion of this pop-up where it says set values for parameter and click on the down arrow. And we're going to go ahead and choose the lookup option. And then we need to reference where our lookup field or file is. In this case, we have a file saved for us already that we're going to use. Later, I think we'll create a lookup table on our own. This one's going to be a shared one. So I'm going to go ahead and just paste that shared location in there. And I think I have everything filled out. Oh, and then I need to select the field for values. I'm going to say event type for that. So I'm going to put event type right there. So once again, opening the manage parameter settings screen, going to the set values for parameter, selecting lookup, pasting in or typing in this specific lookup field or file, and then selecting the field, which it should kind of pop up automatically, and then clicking save. And so now what's going to happen after a moment or two is now when I go to my event type, it should reference that lookup table, and it should, there we go, now show me those values that are in that lookup table. And so now I can just select them. I don't have to type them in. And so now if I want to look at just like, I have AWS console sign-ins, I select that, click start, search occurs, and we don't have any purple because those were all the API calls. Put it back to everything. Now I'm seeing everything for everybody. All right. Okay, still a little more to this lab, but once again, any questions? I hope we're together. Yeah, once again, just let James know. But let's keep going here. What we're going to do to start to finish up this lab is we're going to go ahead and add this panel to a dashboard. So like I showed earlier, I had that security dashboard that had the map and the suspicious login and other stuff. We're going to create our own. And what you're actually going to be able to do is take that dashboard we create and use it in real life. So if you're using CloudTrail data, you can take this dashboard that we create, export it, import it into your real environment, modify the source category, and you can use the data. And so we want to show you that. So you do kind of walk away with a little bit of a takeaway today. But let's go ahead and get this panel into a dashboard. So as a reminder to do so, just click Add to Dashboard. You want to give your panel a name, so don't feel the need to go too crazy with it, but something that expresses what it is. And then you're going to want to provide a new dashboard name. And so I'd encourage you to use your initials and maybe the number that you logged in with, or some kind of sequence like that. Click Create New Dashboard when you do. We're going to use the old dashboard UI. You can play with the new one if you want, but these queries, they need to be modified for the new one. So it's just a little bit easier just to use the old one. And then we click Add. And what we have is our dashboard with our panel, with our filters. And so now what we can start to do is we could say, hey, show us those API calls. And now we're starting to see that. So I know that's a big lab. I forgot how big it is, but hopefully we made it through. Any questions, of course, please ask. What we wanted to show you here was, a lot of different things. Certainly the queries, certainly the JSON data, which we'll use a few times today. The ease of use of parsing that data through JSON. Implementing these parameters, which is a new, well, it's been around for a while now, but was a newer feature, and I think it's pretty helpful. And then turning it into a chart. And then so on and so forth. More parameters, lookup table. Yeah, there was a lot going on in that lab. But hopefully, you made it through. Yeah, let's continue. So lab number 2 seems like a good place to go next. So in lab number 2, what we're going to do is geolocation of console login. So like that map you saw earlier, and some of you, had a question about it, you're about to create it create it and play with it. So let's go through these steps. Now, once again, we're going to do a new log search. And I'm going to, like I was doing, grab the data and just kind of paste it in. I'm going to grab not the data, but the steps in step 2. And I'm going to set it for the last 24 hours. And then click Start. And so once again, what we're doing is we're looking at that CloudTrail data. We're looking at then those fields that we need. And so for this exercise, we're using a couple different fields. Really just one different field. Because what this field is going to show us is the ability for somebody to log in, whether they successfully logged in or not. And that's what we want to see here. We want to see where are people logging in from around the world. Now, what we're going to do here is we're going to very simply, I'm just going to say simply, and we're going to do this a lot, is grab these 4 lines. Because these 4 lines are going to create that parameter filter that we created previously, but by just pasting in the 4 lines. So I'm just going to grab the 2 lines, paste them in, going to grab the next 2 lines, paste them in, click Enter or click Search, And then I will need to go to the parameters and enter stars or wildcards to make sure I get data back. And so we're going to do copying these 4 lines, like I said, a lot. All right, so hopefully you're up to this step, and yeah. Now, the next step here is going to be utilizing the geolocation. So in this case, we're really just using this line here in step 7. And so I'm going to copy it, and actually I'll copy the, so I'm going to use step 8, and I'm going to copy the last 2 lines and go over each line separately. Now, what are these 2 lines that are important enough to go over separately? So first, let's go over this line. What is this line doing? What this line is doing is utilizing a lookup table. Now, we used a lookup table just a few moments ago where we looked up the event types. We just created that, or we just referenced that lookup table. Now, another lookup table that you can use is one that we house as well, and it's showing geographic data like you saw in the maps. This data is not Sumo Logic data. This data is a company called Newstar. It's their data because that's what they do. That's what their business is around, is geolocation of where users are and where their internet is coming from, and that kind of thing. And so we're allowing you to use their data. And so that's what this lookup table is doing. Now, this lookup table, reading the query language, you're going to want to read it from right to left. And so let's go ahead and read this and show you what it's doing. What we're going to do is we're going to take the source IP, and the system is going to compare it to the IP that exists within the geolocation lookup table, that table of Newstar data. From that table, the system is going to extract this regional information: the latitude, the longitude, the country name, the city, the region. There's some other information you can pull, but those are the good ones. So now when I click start to run this line, the system's going to look at that IP and provide all this geographic information. And so let's make sure it does. Now, what I'm seeing here is Ankit logged in from this IP, which is associated with this latitude and longitude, which is located in South Korea. So he logged in from South Korea. Now, once again, if he's never been outside the United States, this could be problematic. If he's in Korea on vacation, this makes perfect sense. And that's what this is starting to show you. Now, what we're going to do is we want to turn this into a map. Right now, we have our raw log messages and our parsed fields, but we still just have the log messages. What we need to do is aggregate this data. So what we're going to do here is aggregate it. We're going to count the data by all this stuff. We don't really need to count by all this stuff, but we will, just because the lab wants us to. And now what I start to see is Kevin logged in from this IP address in China. That might be concerning. Mike logged in from this IP in the United States. That might make sense, and so on and so forth. But to put this data into a map, all we need is the latitude and longitude. Once we have that, we should see this map icon. And very simply, by clicking on it, we should now see it. Now, it kind of does this weird replicating of the world thing at this view. This is a better view where now it's the map, and we see what's going on. And so we see people coming out of Australia and New Zealand, and all over the world. And once again, if we're not expecting anybody in China, this might be quite concerning right here. If we're doing some unique testing, or then it could make sense. And this is test data, or fake data. So yeah. Cool. So hopefully that illustrates just how easy it is to create a map. Basically, you really need IP addresses, and then you need to run lookup, and that's about it to create a map. Very easy to do, and very effective as well. Now what we're going to do is, like we did earlier, now we're going to take this map and stick it into the dashboard. So we're going to go back to add dashboard on the bottom right. We're going to give the map a name. I'm not feeling very creative. I'm going to reference the same dashboard that I did earlier. I'm going to click add. It's going to give me this pop-up about the filter already exists, and that's okay. We want it, so we just want to add panel. This is the conflict it's alerting us to, is we want that to conflict. So we're just going to click add panel. Now we're brought into our dashboard with our 2 panels. And now we can start to filter even further. If I want to filter just on Kevin, he might not have logged in. Let's see who else. Yeah. So now we see Ankit's user activity from a graphical standpoint, and then from a map, I see he's been all over the place. Once again, test data, he's not real, but certainly his traffic is for today at least. And then let me just go back to the lab, make sure, yeah, and then that's it for the lab. So let's see, questions. If you haven't, just someone has a question about having an error in the dashboard. I would just try it again. You also might be in the new dashboard mode. Yeah, we'll have to take a look at that. But I think everybody else is okay. All right. Let's keep going here. So lab number 3. What we're going to look at now is, as it says here, a top 10 number of failed login attempts. So what we want to do is we want to start to look at failed login attempts. Now, once again, do failed login attempts mean a malicious hacker is attempting to brute force their way into a system? Maybe. And that's where we're going to provide, and you can go ahead and evaluate. So this lab, we're going to go ahead and look at that. The first portion of the lab is going to be very repetitive again, which is okay. I think repetition's not terrible. So what we're going to do here is we're going to grab really the first chunk of this query. I'm going to grab, actually, I'm just going to grab the whole thing and then just talk through it. So new log search, paste the query in. I'm going to turn off these last couple of lines and go through these manually, manually. So once again, we're grabbing the CloudTrail data. We're grabbing those fields. We're going to grab an additional field because we want to check console logins. We want to check the status of the console login. So I'm going to run this query as is. Now, the success of a console log, the value, the result of the console login rather, can either be a success or a failure. Now, we may want to see where the result is a failure. We may not want to. And so that's what we can decide is, do we want to see where a user logged in successfully or where they just tried to log in? And so we can go ahead and select that. And that's what we're doing here with this value. And we're also saying specifically to use the AWS console sign-in. Last 24 hours. So with this result, we're saying only show us where somebody failed to log in. If they successfully logged in, that's fine. And we're actually going to do another lab kind of around successful logins, but in this case, just look for failed logins and just look for this event type. Now, we probably should have, in fact, I don't know why we do in this lab, we should have actually filtered for event type right here. And we would create a whole filter, and not for nothing, but we did do that. So, but we just don't, we just show it this way. Once again, kind of 2 different ways to do the same thing. Now, what I'm looking at here is my 24 hours worth of data. So over the past 24 hours, I'm seeing the information, the user, what they did, the failed login, where they did it from. What I'm going to introduce now, and we saw this yesterday, is something called time slice. What time slice gives me the ability to do is take my data in a group of time and break it up into chunks of time. Rather than looking at data in the last 24 hours, look at data in groups of 1-hour buckets. So look at data from 8 o'clock to 9 o'clock, from 9 o'clock to 10 o'clock, from 10 o'clock to 11 so on and so forth. And that's what I'm doing here with this time slice. I think yesterday we used the time slice of 1 minute. We can use one of 1 hour. Many different options there. And now I'm going to count the data by time slice. So now what I'm going to get is for each bucket of time, each 1 hour period, the user, and essentially what they did and how many times they did it. Now we can go ahead and use that top operator again to sort the data, to see the top 10 actors, the top 10 users. And when we do, we can sort by count. There's not too much data in here for this, but what we start to see is Ankit from 12 to 1 p.m. failed to log in twice. That may or may not be curious. Probably not. It could just be if, he forgot his password twice in an hour, or even, the typo, fat fingered it. But this is what the data is showing us. And then once we're going to do, once we have this, is once again, we're going to add it to the dashboard. So fail, really spelled all that wrong. Failed logins, JB345, add panel. And now I have my third one here. All right, let's do another lab or two. Time we're pretty good. So yeah, let's keep going. Into lab number 4. So lab number 4 is going to be account compromise. What we're going to do here is we're going to go ahead and look at or look for brute force attempts. A brute force attempt, for those of you who don't know, is when a hacker, or I guess somebody, well, it doesn't have to be malicious, I guess you could do it as a white hat, is going to try multiple login combinations to get into an account. So they might have a login, they might try one password, then another password, then another password, and over time force their passwords into the system and hopefully hit one that works. That's the goal. So the way that we can detect brute forces is by looking at the CloudTrail data and looking for a high number of failed login attempts within a period of time. Because if somebody in an hour or 5 minutes or whatever period of time tried to log in 100 times and failed, that could be indicative of brute force. Now, once again, it could be Bob is really forgetful and kept trying that password 100 times, couldn't get in because he forgot he changed it last week. So once again, it doesn't necessarily mean that there is that malicious hacker, but it's certainly indicating that type of behavior, which is suspicious, which we want you to look at and investigate. Now, the query, once again, repetitive in that a big chunk of this is very repetitive. So what I'm going to do is I'm going to go to step 9 and grab the whole query and then talk through it like I've been doing, which I hope is good. So new log search, paste it in, last 24 hours, wildcards in there. And then let me go over these last group of lines. And so I'm going to run this query just as is, just to make sure I get data, which I'd encourage you to do. Yeah, it can be annoying if you paste it in, edit it, run it, there's nothing in there, then it can be harder to troubleshoot. So, but I got everything in, pasted correctly. So what I'm going to do here is I'm going to use that time slice or introduce that time slice like I did earlier. So I'm going to be ultimately breaking my data into 1 hour buckets because that's how I want to look for a brute force attack. I want to look at a 1 hour period and see how many times did somebody try to log in. A 24-hour period is too wide, but a 1 hour period, I should be able to see if somebody's trying to log in multiple times maliciously or not. Now, how am I going to determine whether or not somebody is logging in a large amount of times or not? How do I decide that? And maybe decide isn't the right word here, but what I can do is I can basically have the system start to calculate how many times somebody logged in unsuccessfully and successfully, and then start to turn that into a ratio or a percentage and figure out, out of X amount of times, how many did they actually log in successfully? And that's what we're doing here. So what I'm doing with this line here of if result equals success 1, 0 is when I run this line, the system's going to create a field or a column, well, a field, I guess, for success count. And based on if the result is a success or not, it's going to put a 1 or a 0 in there using, kind of binary, yes or no, true or false. And so let's just take a look at how that works. So I'm adding this line. I now have a column called success count, and I'm either going to have a 1 in that column if the result is a success, or if I have a failure, I'm going to have a 0 in that column. Now what I'm going to do is I'm going to create virtually the same thing, but I'm going to call it failure count. And if I have a failure, I'm going to put a 1 in that column. And if I don't, I'm going to have a 0. So now I have that new column called failure count, and I either have a 0 or 1. So every log message is either going to have a 1 in the success count or a 1 in the failure count. And whichever one it doesn't have will be a 0. Now what I'm going to do is I'm going to add them all up. I'm going to take all those successes, take all those failures, and add them up and group them together by time slice, actor, and event type. And so what I now see is from 3 to 4 a.m., Ankit tried to use, or using the AWS console sign-in, logged in successfully 66 times and failed to log in once. So out of 67 login attempts, 66 were successful. Now, once again, if Ankit's on vacation, this could be malicious, but in this case, this seems like normal behavior. Ankit logged in successfully. Good. All right. Yay. What I'm going to do is I'm going to take this and I'm going to turn it into a failure percent. Basically, take the failures, divide them by the successes, multiply it by 100. It's probably not the perfect solution for a ratio, but it kind of gets me there. Because what this now shows me is, or will show me, is failure rate percentage. Here, 8 successful logins and 1 failure versus 97 successfuls and 1 failure. So in this case, if you're thinking about like a percentage, it's 97 out of 98. Here it's 7 out of 8. And so these numbers aren't great. It would actually be better if we had more fails. Our fail column is a little weak here. Let me see if, so here's a better one. But now we're starting to see something that might be suspicious. Like I said, the data isn't the greatest for this example, but hopefully it's sort of illustrative. And now, once again, we'll take it and stick it in the dashboard and call it brute force. Let's do another lab or two and then we'll take our break. Yeah, no questions. Or James has been answering them, so I think we're good. So let's go to lab number 5. Lab number 5. This one is quite a lab. Yeah, let's do this one. So, all right, lab 5, let's get into it. What we're going to do here is we're going to detect a land speed violation. Now, what does that mean, or in this context? A land speed violation is going to occur when a user logs in from one location and then logs in from another location within too short of a time period to be practical. So for example, as it says here, if a user logs in from Australia and 3 hours later logs in from Brazil, that's not physically possible. And so the system can let you know that. Now, once again, does that mean a malicious hacker? Well, no, somebody could be using VPNs, but we're going to assume not here. So what we're going to do here, and this is where it's going to get very in the weeds, and just bear with it. It gets really nerdy and mathematical very quickly. But hopefully you'll see the benefit. Just like I said, it gets really in the weeds. What we're going to do here is we're going to, and we'll do these steps, but basically what we're going to do is we're going to grab our data. We're going to grab our users and IP addresses. We're going to filter out null IP addresses. So we only want valid IP addresses because the lookup only works on valid IP addresses. We're going to start to create a clock, if you will, of when the user logs in and how many times the user has logged in from the IP address. We're going to filter out single logins because we're looking for somebody that's logged in multiple times during a time period, not just one login. We're going to do some conversion of taking our IP and converting it to a decimal and then converting it back to an IP address. And this is where, you know, the nerdiness comes in. It's just a feature of how the system handles IPs, not something you'll be doing every day by any means. Then we're going to go ahead, once we have that IP address, we're going to do a geo lookup. We're going to look up with that lookup table where that physically is in the world. Then what we're going to do, getting nerdy again, is we're going to use what's called a Haversine formula, which is going to allow us, or allows the system, to use the data and see where is one point in the world, where is the other point in the world. The world is not flat. Sorry to break that news. It's a sphere. And so it's not just a direct line. You have to take the curvature of the Earth into play from going from one point to another. And that's what this Haversine formula does. It lets us know that Australia and Brazil are not a straight line. With the curve, it's actually this many miles or kilometers. Then we're going to where the system is then going to tell us if that person was in Brazil and Australia, how fast they would have had to travel in order for that to be successful. Now, if Brazil to Australia, 3 hours, they would have had to travel at, you know, not faster than the speed of light, but quite faster than planes can go currently. And so what we're going to do is we're going to specify a speed that is impossible. If you can't travel more than 500 kilometers an hour, maybe you can with, you know, space, but yeah, I mean, it's not really practical. And so then we're going to produce the results, which will then show us this person logged in from here and there. He couldn't have physically traveled from here to there in this amount of time. And so that's suspicious. So let's go through the query. Like I said, it's going to get very in the weeds. So I sort of apologize for it. I mean, I guess it's helpful, but some of it I'm just kind of going to brush over a little bit. So let's go ahead and start to put it together. So I'm going to grab the stuff in step 2, which is once again just going to be our CloudTrail data and us starting to parse that data. So nothing really new in that first 2 lines. Once again, IP address and user. Now we're going to grab in this whole portion next. And what this portion is doing is, well, it of course sort of describes it. It's looking at the IP addresses, starting to create a clock, if you will, and also looking for IP addresses that are public IP addresses. This IP address lookup does not work for private IP addresses. So IP addresses such as 192 or 1720, those are reserved for private IP ranges. And so if you're using a private IP range, we or nobody can tell you where that physically is because it's a private IP range, it's not public. And so the system is looking through that and then sorting the users by that login time. And so starting to kind of group them a little by message time as well. And so once you run that query, the results should look about like this. So what we're seeing here is Siraj logged in from this IP address at this time, and it's being expressed in APAC time, which is another format of time. Now what we're going to do, and this is where it gets, just take it and copy it, is we're taking the IP addresses, we're going to convert them into a number with octets. And so we're just taking those IP addresses and breaking them out. This is not something you would do, like I said, on a daily basis, maybe ever again. So it is a little weird for the lab, but it's doing what it says. It's taking it, converting it into a decimal, then converting it back into octets. And those octets are the portions in between the dot of an IP address. So something dot something dot something, that something is called an octet. And so we're seeing those here. And once again, we don't really need to see it. It's just, this is what's going on. So we have our data, we have our IP addresses, and we have previous IP addresses. So this is where Siraj logged in from. This is where he previously logged in from. And now we're going to continue to take this and start to figure out the distance between these 2 points, the times of when he logged in, and deciding if that's physically possible to do. And so we're going to go ahead and use the geo lookup. What we're doing here is we're doing 2 lookups, essentially. We're looking at the current IP and the previous IP. So for each login, we're looking at 2 IPs, exactly as I said, for the previous one and the actual one. And so we're starting to see here, it's starting to form together. Here we see Siraj in this line 2 here has logged in from the United States and Italy over, actually I should do the last 24 hours. So here we see Brazil and the United States in the last 24 hours. Now that's certainly possible, but what we're going to now start to apply is that Haversine and start to figure out how far apart those two locations are, and then once again, if air travel is possible. And so that's what this portion is doing here. You can read it about it, like as I've said, alluded to a few times. I keep saying nerdy. I don't know if nerdy is the right word. It's certainly interesting, but it is in the weeds. But it's helpful too. It's going to express it in kilometers, which is helpful as well. No need to translate to miles. And so now we're starting to see. Here he logged in from Canada. Here he logged in from the United States. They're this far apart. Now in 24 hours, that's possible. And so now what we want to do is fine tune this and what time did he do this? What time did he do that? Could he have flown by plane? Yes or no? So that's what we're going to kind of continue on here. And that's what we're doing with this portion here. What we're doing is we're calculating the speed a user would have had to travel in order for that to occur. Let's see. So what we're starting to see here, for example, this person logged in from the Czech Republic and the United States in a 24-hour period. He would have had to travel 860,000 kilometers to get from the Czech Republic to the United States when he logged in from this IP to that IP. Can you travel 860,000 kilometers per hour? No, I don't think. So, that's suspicious. And then we're going to have the system let us know when that happens. The way we're going to do it is using this portion here. We're going to define what is suspicious. We're going to say, if it was 500 kilometers per hour or more, that's suspicious. But if it was less, that's certainly possible. And so what we should be left with is, actually we need to format it. So we're getting there, but we're now starting to see those apparent velocity and then the suspicious. So all that's left are suspicious, meaning more than 500 kilometers an hour. And then what we're going to do is just clean it up for, like it says, for presentation. So we're going to go ahead and we're going to take the field, we're going to concatenate them, combine them. Yeah, let's just show you what it does. There we go. So now we're starting to see Joe Schmo. He logged in from Australia. He logged in from the United States. That far apart. He would have had to travel 67 trillion kilometers per hour. So likely he logged in 1 second, and the next second he logged in from another one. And then, that's not physically possible. Now, once again, if he's testing VPNs, makes perfect sense. If Joe Schmo doesn't work there anymore, that's quite curious. And then we're going to take this panel and add it to the dashboard once again. So I'm just going to call it speed, JB345, add, and there we go. There's my data. And now we're starting to see that. So cool. All right, why don't we take a little break? Time-wise, we're doing well. So let's do, we'll do a 10-minute break again. I think everybody likes 10 minutes. So once again, we'll take a break. I'll get a little snack. I encourage you to grab a snack or a beverage. We'll come back. We'll do 3 more labs, and then we'll get you taking the exam, and then that'll be it. So, like I said, I'll step away. Any questions, put them in the chat. I know James has been answering them, but keep doing so, and yeah, we'll keep going in shortly. So, see you all in a little bit. Welcome back, everybody. Hopefully you had a nice little snack or beverage or something to keep you through the morning. Let's go ahead and pick back up and finish up the next couple labs. So lab number 6 is going to go more into lookup tables. So we're going to use the parameters that we had started to, well, that we did use already, but we're going to turn those into a lookup table. So we showed you today, let's see, in regards to lookup tables, we showed you that shared lookup table that we used earlier, that event type, I believe it was, or event name, one or the other, I can't remember, event, one of those. We showed you the lookup table that exists for geolocation data, so geographic data, that new star data, the geographic data. What we're going to show you now is how you can create your own lookup table. And we're actually going to use another lookup table in lab 8, but let's get there. So how can you create your own lookup table? Well, here's how to do it. We're going to go through it. It's pretty easy. So I'm going to grab, in lab 6, I'm going to grab step 1. I'm going to grab all the steps, and I'm going to go through it line by line like we've been doing, and show you why we want to create this lookup table. Now, like I said, I was going to go line by line, and then I didn't. There we go. Come on, mouse. There we go. All right. So what we're doing is we're looking at our CloudTrail data again. So why are we doing this lookup table? Well, what we want to do is we want to populate the actor field, or the actor values, really, I guess more specifically. We could go ahead and manually type in one of these actors, one of these users. The problem here, or not, problem is we need to know the user's name, and specifically the spelling, whether it's capital, whether it's not, case sensitive, all that stuff. And if we do, that's great. But what we want to do is we want the system to populate this actor list so that we can just select from one of the actors that exist in the system. We probably are not going to know all the people that exist. So we want to have a pull down, basically. And so we're going to create a lookup table from that, or for that. Now we're going to look at our CloudTrail data first, like we've been doing, for the entire day. I think we've used all CloudTrail data so far. We're going to go ahead and look at the users. So we're going to look at that field that we've been using today as actor. We're going to look for it. So we're going to look for all the people, all the users over the last 24 hours in CloudTrail. We're then going to count by the users. The reason we're counting is we want to get that aggregation. And so what we now see is the data aggregated, grouped together, in this case, grouped together by the counts. So here we see over the last 24 hours, Ankit has shown up 10,000 times, Kevin's shown up 15,000 times, so on and so forth. Now, I don't really care how many times somebody showed up. The fact that they showed up is important to me because that means they are an actor, they are a user. I want to be able to select them. But if they showed up one time or a million times, it doesn't matter to me. And that's what I'm doing with this next line. What I'm doing here is removing a field. I'm removing the count field. And so I'm really just minus underscore count. When I run it, it's just going to remove that count column. And now I'm left with a list of actors, a list of users. What I'm now going to do is save that list of users. So I'm going to save it to save shared. And like it says here, I'm going to use JB345. I'm going to copy that just so I remember it because I've done this live a lot. And now I'm going to click search or run. When I do, the system's going to ask me that, do I want to run this query because I'm saving something? It's just confirming, and I do. So I'm going to click run. And now I should have a lookup table saved to this location. Now, prove it to me. How do you prove that there is a lookup file? Well, what you can do is you can use a cat command. It stands for catalog. And basically what we're going to do is we're just going to do a new log search. We're going to then do a cat space, that location of that shared file with a T. And what I should get when I click start, if all goes well, is I should now get a list of those 12 or whatever, 15 users. And I do. So now I have a shared lookup table. You should also be able to use my shared lookup table. So since it's shared, you should be able, and I'll paste it in to see, allow you to look at it, or if you want to. But now, I could tell, Bob on my team, hey, Bob, I saved the list of actors to this location. Go utilize them. And now he has a built-in lookup table. Now, what we're going to do to continue this, or take it a step further, is now we're going to associate this lookup table with the parameter setting so that it populates that fill-in portion. And the way we're going to do it is just like it shows here. So what we're going to do is we're going to go to, well, like it says, so we're going to go to our dashboard. We're going to look for one of the queries. So I'm going to go to my dashboard. I'm going to select one of the queries. And I'm going to click this show and search, this icon. It doesn't matter which query we use, which is good, makes it easier. Once I have that query that I selected, I'm going to go to the actor and I'm going to go to manage parameter settings. Now we started to do something similar, but we're going to do it a little bit differently here. We're going to go to set value for parameters. We're going to go to lookup. And now we're going to, once again, kind of fill in the blanks. So we're going to specify where is our lookup file. Well, mine is that shared, JB345, and you can use mine if you'd like, or use your own, which I'd encourage. I'm going to select the field for values. There's only going to be one value in there of actor, so I just need to choose it. And I'm going to click save. System's going to kind of put it all together. And now when I go to my actor, actually, look up, and click save. It should start to, there we go. There it goes. And now when I go to my actor, now I have that pull down menu. And what I can do here is I can also choose to update the dashboard. And what that should do it should allow me to now go to my filter, and my actor should show up the list here. Let's see. Fingers crossed. Come on. Let's see. Why didn't it? It should have populated in there. Let's try it one more time. I don't want to have you waste time watching me try to get this to populate. But it should have filled in with the actor. It will here if I do it at this. Oh, here we go. I'm not sure why it's not. It's user error, I know. Hopefully yours is showing up. If not a big deal. It's kind of last lab anyhow. But ideally what you should see is a list of actors in here. And it should be a pull down. Yeah, I don't know why it's not working. I'll check after, like I said, I don't want to tie up our time troubleshooting that. It has worked previously. Yeah, I don't know. I'm not quite sure where it's not in there. But we could also just replicate it going to each dashboard. We should be able to do it as a whole though. But hopefully, I apologize, a little bumpy there, but hopefully you got the idea of creating that lookup and referencing it. All right, actually 2 more labs. So this next lab is having us export this data out. So I described this earlier, is if you want to, not required, of course, but basically you could take this dashboard that you created, export it out, import it into your real environment, modify the source categories, and assuming you're using CloudTrail data, this query should still pull up a map. It would just say, might be prod or whatever it might be for you, but that's the modification you would need to do. So I'm not going to go. You can go through this lab. It's just exporting and importing. I don't think it's that needed right now. I'd rather give us a few moments back of time, to be blunt, but it's having us export. It exports as a JSON, which is very helpful as well, so that you can modify that JSON if you want to. And then what we're showing you here is just, like I said, grabbing that JSON, putting in a text editor, and then just doing a very simple edit and replace for the source category value, and then importing it back in to your environment, and then running the queries. And it, like I said, it should work. So feel free to do that. It's not required. It's meant to be helpful. I'd encourage you to, but like I said, I don't want to have spend too much time going through that. Let's see. Oh, good question. I'll answer this one live. The question was about when creating a lookup table, is the data updated automatically over time or just once off? It's updated over time. So every time you reference that lookup table, it's going to look at that lookup table for the first time and pull the data back. So you can create a lookup table that is constantly updating. We don't go to that level deep in this course, although you kind of have the tools to do it already. But it does do it automatically. So hope that's what you want it to do. So I answered that one live. All right, let's do lab number 8. Lab number 8 is a good way to end for a few reasons. One, it's security related, but it's related to another lookup table, and this is CrowdStrike data. So for lookup tables, we've talked about, the lookup table we just talked about. We talked about the geographic data a few times. Well, there's another lookup table, and that's CrowdStrike data, as I just said. CrowdStrike is a company, a US-based company, and what they do is they are experts in threat detection, threat investigation, threat intelligence. And so in the same way, this Neustar company is an expert in geolocation, CrowdStrike are experts in threat intelligence. And so we're giving you essentially their data. Their data is quite expensive. And so yay us that we give it to you for free. But what we're going to show you is how to utilize it. And so let's go ahead and do so. This first portion of the lab, I don't really like either. I really need to edit a couple of these labs. Let me describe what's going on here. What we're showing you here is, before we even get into the CrowdStrike data, we're showing you 2 different ways to run a query. Something called a scheduled view, and then the way we've been doing it, throughout the past 2 days. What the scheduled view allows you to do, or the system to do, is to take a query and run it repetitively in the background and keep the results. So it's going to run a query, bring the results back, run a query, and consistently every minute it does it. And so what it allows you to do is essentially request results for a time period, and rather than waiting for the system to produce those results, it's going to provide those results that occurred 1 minute ago. And so it's a way to handle large scale data sets. And so we're kind of just showing you that here. I don't really know why we're showing it to you here. Not why, I mean, it's a practical thing, it's useful. I don't know. I don't know why we put it specifically in this lab, but we are. Because it does allow for a faster response time. I mean, it is a helpful feature. I guess I shouldn't poo-poo it that much. It is a good feature that we have here. It's just a weird spot we put it in. So what we're showing here is the scheduled view, the idea of it, and that it's running. And so you can actually go in here and take a look at it. So if you go to manage data and logs and scheduled views and IP threats, you're going to see this query. Now you can take this query and copy it and paste it and run it manually, or you can run it as a scheduled view, which is what we're trying to show you here, is that ability. What we want you to do, though, is we want you to take the query from the scheduled view and run it, which defeats the purpose of the scheduled view, but nevertheless, that's what the lab tells us to do. So what I'm going to do is I'm going to go to manage data. I'm going to go to logs. Sorry, I forgot logs. Go to scheduled views. I'm going to look for the IP threats, excuse me. And I'm going to copy this query. Now I'm going to paste it into the chat so you can just copy it as well if you don't want to go through that whole journey we went through to get it. But regardless, I'm going to get this query. I'm going to take it. I'm going to paste it in, and I'm going to run it. Well, I'm going to run it, but I'm also going to talk about what this query does, because here's the results, but how do we get these results? What are these results showing us? So let's look at the query and try to understand what it's doing. So first, we're saying, look at all our data. Don't look just at CloudTrail data. Don't just look at AWS data. Don't just look at O360. Look at all the data. You can modify that to be whatever you want, but in this case, we want to show you a lot of data. So look at all the data. From the data, look for an IP address using regex. So the system is going to go to each log message and look for number. If it finds it, it's going to retrieve that as an IP address. And so now we have for each log message, we have, or we're starting to get there. I guess I should get our raw messages. We have our IP address extracted from the log message. Now here we're doing similar as we did in the previous lab, in that we're saying don't use those local IP addresses, don't use those private IP addresses, because once again, they're not going to be revealing. That's why. And now what we're doing here is we're going ahead and using that lookup table. Now, remember, we used the geographic version of it. Now we're not. We're using the threat intelligence, and it reads similarly right to left. So what we're just saying is take the IP address and compare it to threats that exist within the CrowdStrike environment. So instead of looking at geographic, look at CrowdStrike. From that data, don't grab latitude and longitude. Grab these things: type, actor, the user, threat level. Threat level we're actually going to rename to malicious confidence because we just want to. And then what we're going through here is starting to just filter more, just kind of filter it and ultimately produce this. And what's produced here now is an indication of possible security events from CrowdStrike's view. So what CrowdStrike is saying is this IP address showed up at 432. It is known to have a high malicious confidence, and it's showing up in the guard duty data. And so what's occurring here is basically it's starting to evaluate, is this concerning or not? Let me see if I can find. I want to find a low, not necessarily unverified. Never mind, I don't want to take that. But what we're starting to see now is this categorization. So for example, here, this IP address was found in our labs window JSON data. Well, we use our labs data, this is lab data. But this actor, a charming kitten, which sounds cute, but is actually a malicious malware, is associated with this IP address. And so once again, what do we do with that? Do we blacklist this IP address? Do we monitor it? Do we delete this lab data? We need to decide what to do with it, but that's what we're seeing here. And with this malicious confidence, as I was starting to say, I couldn't find one, or actually we can just sort on them, is we can have, let's see here, malicious confidence. We can have different values here. So if it was a malicious confidence of low, that might not be very concerning. But if it's high, that's, CrowdStrike is letting us know, bad actor, be concerned. Low, okay, it's probably safe. And so that we're getting that information. And then we're getting this kill chain information to really start to describe about the IP address, what it's associated with, what nefarious kind of activities have occurred. So, there's another portion to this lab, the outlier portion. So we'll show that in a second. I see there's a couple questions. Let me go ahead and just address them. The first question, or really more of a comment appropriately or correctly, is about the actor parameter. Why it wasn't working here for me. And what I needed to do, and the lab did say it, I rushed through it, is I should actually go to each panel and link that lookup table. And so then when I use it for all link panels, it should work properly. So that was me rushing. Yeah, I just got a little ahead of myself, so I apologize for that. And then I think that's it for questions. Yeah, I think that was it. So, okay. So that was just, human error there. All right, let's see. Yeah, that's it for questions, I think. So, so another portion of this lab, sorry. So we now have our data. We now have this information. Here it is. What we want to do here is we want to go ahead and introduce or reintroduce the outlier feature. This is the feature is great. This is also kind of a weird spot for this in this lab, but it should still work. So let me go ahead and show you what this does. I'm going to take the 3 lines of code, I'm going to paste them in like we've been doing and go through each one. Now, what I'm going to do with the first line here is I'm actually going to get rid of a lot of these fields. I don't need them. They're just not relevant to what I want to show you. So I'm just going to remove them. And so I'm doing a minus IP address, minus, etc. And let's see. So what we're starting to see here, so what am I starting to see? What I'm being presented with now is, I got rid of a lot of this, but what I'm basically seeing is how many IPs CrowdStrike observed during a 1 minute period. That's kind of the summation of what I'm seeing. So here it found 3 IPs, here it found 2 IPs, here it found 6 IPs. And so it finds a variety of different IPs. Here it finds 26 in a minute, sometimes that's 2. What is a normal number, or what is an acceptable or normal number of IPs that it should find? Is 25 IPs in 1 minute a lot or a little? Well, it seems to be a lot. If I'm sorting by count, it's second highest, but I might not know that. What I want the system to do is to figure that out for me. And that's where I'm using this outlier feature. And I think I showed this yesterday. What the system is going to do, let me go ahead and do this now, is it's going to use the outlier operator. And the outlier operator is essentially using all this math to look at values, look at current values, look at previous values, and figure out what is normal and what is not, and then alert us or let us know when it's not normal. So it's going to take a few minutes. I'm actually not doing that much data. Actually, I'm doing a lot less data than I thought. Let me do more data because it will just illustrate better. So I'm just going to expand it out to 60 minutes. Actually, I'm going to do this as well. Okay, perfect. Here we go. Although it's still loading, so not super perfect, but it's just about done. So what is this showing us? So here, for example, now I'm doing 60 minutes. I'm doing a lot more data. My numbers are now, 25 was a high now, but now different numbers, different data set. So here I had 1,700 IPs were found in that 1 minute period. Or is it done? It's still loading. So here, for example, I had 739. What the system is doing is saying, this is what the system considers to be normal, the lower and the upper, and it's still loading. So I apologize. The numbers are kind of fluctuating here, but it's starting to look at what previously occurred and what's normal. And so here it's saying, okay, I consider 825 to 1800 to be normal. All right, it finally loaded, by the way. So I consider to be 1000 to 1800. Anything in between there, that's a normal number of IPs to show up. And it does, it's a normal number. The next time period, the range changes a little bit based on previous values and math. And now the range is a little tighter. Now it's 1148 to 1800. This value is still within that range. And so that's considered good, normal, acceptable, whatever kind of adjective you want to use. Let me fast forward here to this spot. Here, based on all the math, the system is narrowing itself. It's now saying what is normal is between 1200 and 1700. The actual was 1800, which is outside that range. And so what we see here is a 1 representing this is outside the range. Now, what we can do is we can use this line chart. And what we see here is very simply what's been going on. The blue line represents the count of IPs over that minute in time. The cloud of upper and lower light blue represents that upper and lower threshold limit. And the pink triangles represent those outer limits. And so what we see is over the past 60 minutes, there's been 2 times where we had more IPs than were expected. Now, does that mean a malicious hack? No, maybe, maybe not, but it's certainly letting us know this behavior is not quite normal. And so then we could turn this into an alert and get notified, and then we could do whatever we do. Maybe we need to stand up new servers to let in more IPs. Maybe we need to update our IP checking or blacklist, or, there's so many kind of what ifs, but this is what the system is showing us. So the outlier is really a valuable feature, and I don't know if I really did it justice here, but it really allows you to have the system determine what's normal and what isn't. You could create a rule or just a line of code that says, if there's more than 200 IPs in a minute, that's bad. But that's not dynamic. It doesn't grow. It doesn't shrink. It's static. The outlier is dynamic. So it does look at previous traffic, does a bunch of math, and then gives you that range. And I'm referring to it as math. I'm keeping it just vague for now. It goes, you can read about the outlier. It's very in depth. There's different, just different features of it. So I'll paste it in the chat. I don't want to go too deep on it. I could, but I think just the fact that it exists is kind of more important for you to know today. All right. So that concludes the labs. Any questions? I mean, I know we're kind of we're good on questions as far as those that have been put in, but anything else that you have questions about that we covered today or not? Feel free to ask. Now's probably a good time. Otherwise, let's go ahead and start to talk about the exam. So, if you have a question, put it in, but let's continue here. So, very similar ground rules to yesterday, but I'm going to repeat them because a lot of us weren't here. So let me just get to my slide on it. So what we're about to do is take an exam. This exam is free for you, free for your organization. It's going to consist of 25 questions, maybe 22 questions. I can't remember exactly. You'll have 60 minutes to take it. If you took one yesterday, you probably learned that you don't need all 60 minutes, but you do have it allocated to you, so feel free to use it. Whoop, where'd my slides go? There we go. Sorry about that. But did it again. And once again, this is an open resource exam. So use your documentation. That's available to you. Let's see what else. Remember to log out of the training account and log in as your corporate or personal or professional account. So we don't want training user 546 getting credit. We want Bob or Bill to get credit for the exam. What else? To get to the exam, I'll just show you in the UI, and I'll show you a few times. So if you're still logging in, let me just get rid of my Apple Music here. I'll show it a few times, but basically, where is it? So once you get logged into Sumo, you'll be on the home page. Hopefully, you're going to go to certification, and then you're going to choose Get Certified. It should take you into the training portal, which certainly if you were here yesterday, you've seen. And then what we're going to want to select is security. So yesterday we did fundamentals. Today we're doing security. And then we're going to select the cloud security monitoring and analytics exam. Once again, Japanese is available. I don't think it's appropriate for anyone here, but if you want to try it, feel free to. And then, once again, go through this. As a reminder, once again, you'll register for the exam. You'll read this little thing, which basically tells you what I just told you. You'll take the exam. Eventually. So you'll start it, you'll take it, you'll do great, you answer all the questions. And then it's important that you click this submit button. So once you get your score, click the submit button so that the score gets registered. Once again, it's a weird behavior that it doesn't, but not Sumo behavior, but we still have to live with it. So make sure you do that. Also, as a reminder, let's see, I'll kind of post these throughout the exam. But once again, the Uber Eats, send us an email, training@sumologic.com. The backpack, I'll go ahead and paste that link into the chat. So if you want to or eligible for that, go ahead and look at that. One thing, there's a question, actually, James is answering it, but I'm going to answer it for the group because it's a good, well, all questions are good. The question is about the most common searches. And what I want to show you is under Home, under Learn, so in Sumo Logic, in Sumo Logic, there's going to be this cheat sheet. So under the Learn tab, What the cheat sheet's going to provide you is a list of all the different operators. Now, that's not exactly what the individual is asking for. They were asking for specific queries, but this is really helpful. In fact, let me just paste it into the chat. This is going to give you all the different actions, all the different verbs, however you want to kind of think of an operator, in a list. So parsing, aggregating, we talked about in aggregation, we primarily talked about count, but you can average data. You can do min max, percentage, sum, search operators. There's a lot of them, and so on and so forth. So a lot of different math things you can do, all kinds of stuff in there. So that link is pretty helpful. Let's see. One other thing I'll give you a link to, this is pretty helpful, is as it says here, general search examples cheat sheet. So it just gives you some structure to queries, kind of as we discussed, but like here, if you want to identify the top 10 pages. So it's good kind of for brainstorming. So I'll include that. All right, so let's see. So we should be starting the exam ideally, and I'm going to shut up in a few moments. I'll also step away. James will be here, kind of same thing as yesterday. Once you're done with the exam, please leave in that you don't have to wait till the top of the hour to make sure everybody else has completed their exam. You're free to go. We'll send out an email tomorrow or maybe the day after with time zones that should have a recap of slides, labs, recordings, all that kind of stuff. That's kind of it. So thank you certainly for attending. Hopefully you found this helpful. As a reminder, and I'll put it up there, send us that, certificate so you can get that free Uber Eats. But otherwise, I'm going to go on mute. Thank you again. And yeah, and once again, if there's any questions as well while the exam's going on or over the next little bit, go ahead and put them in the chat. We're still here. We'll still answer. So, James, anything from your side? I think we're pretty good. I'm not throwing you on the spot there, but I am.
No, those were good answers with the two cheat sheets. Those cheat sheets are very helpful. The only other thing I might add to that is there is a Slack workspace for Sumo Logic. It's called Sumo Dojo. And I can post a link to it. So if you use Slack on a regular basis, it's worth jumping on there because it's other customers, it's partners, it's consultants, it's us. We're out there. You can mention me and I'll help you with stuff. But in terms of this class today, right now, let's stick to the chat and the Q&A here because that's enough for me to manage just 2 things versus 3. Yeah, good luck with the exam. Make sure you log out of the training environment, the lab environment, log out of it and take the exam using an email that's associated with you, either your corporate email or your personal email. So that's the thing that throws a wrench in the works sometimes. So I think that would be it. I'll be around till about 11:50 Sydney time or so in the next 50 minutes or so. But yeah, good luck with the exam and let us know if you have questions.
Great. Thank you, James. And thank you everybody else as well. So yeah, good luck. And we'll be coming back around. So we have more classes coming for you. So kind of stay tuned to however you found these classes. If it was a mailing list or what have you, you'll get more info about some of the cloud sim and other classes we'll be doing in the upcoming months. So great. So thank you again as well. I'm going to put myself on mute and best of luck all.
Hey, Vivek, saw the question you asked. Sometimes this can be the result of being behind a corporate network in a VPN, or maybe your corporate network just doesn't allow access there. So we may have to give you a direct link to the certification. Also, Vivek, be sure you're not logged into the lab environment, that you're actually logged into either your corporate one or your private Sumo account.